Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is June 2020, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Now this particular paper's got a bit of an identity crisis. On the front it's written May 2020, but it's part of the June 2020 paper set. And weirdly it's listed on the AQA website as November 2020. But whichever paper set it is, this is paper 1, which is the non-calculated paper. So let's get busy. Question 1, here are some numbers, circle the range. Okay, well range is equal to your highest value minus your lowest one, isn't it? So here my highest value is going to be the 17 and my lowest value is going to be the 5. So the range is going to be 17 subtract 5. It's going to be 12, isn't it? It's that one. Question 2, circle the value of the digit 5 in 256,934. Well, the 5 is here, isn't it? And there are 1, 2, 3, 4 digits to the right of it. If we just put zeros there, 1, 2, 3, 4 in those same spaces, you can see that that 5 has a value of 50,000. It's that one. Question 3, work out -2 minus 5. Alright, well, if you're on the number line, 0 in the middle, 1, 2, 3 this way, then you've got minus numbers going this way, haven't you? So -1, -2, -3, -4, -5, -6, -7. Okay, so if I'm at -2 here on my number line, and I am subtracting 5, subtraction is this way, isn't it? Subtraction. So I'm going 1, 2, 3, 4, 5 jumps that way. I'm going to end up at that point there. It's -7. It's this one. Question 4. What is 680 millimeters in centimeters? Well, if you look at your ruler, you probably realize that 1 centimeter is 10 millimeters. So if we're in millimeters and we want to go to centimeters, we're going to have to divide by 10 because there are 10 millimeters in every 1 centimeter. So what is 680 divided by 10? Well, divided by 10, we can move the decimal point one place over, can't we? That's going to be 68. So it's going to be that one there, 68 centimeters. Question 5, work out the area of shape A to the area of shape B. These little 2 dots mean to express it as a ratio, isn't it? So we need to find the 2 areas and then express that as a ratio in its lowest forms. So you've got a choice. You can either, you do a bit of maths to work out the area. You could just literally count the squares, can't you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So shape A. So if we're going to do a ratio of A to B, then A is 20. What's B then? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 squares. Okay, so 20 to 12. Okay, but we do need to write it in its simplest form. And 20 and 12 have a common factor, don't they? What are the common factors of 20 and 12? Well, 2 goes into 20 and 12. Is there a bigger one? Let's try 4. 4, yep, 4 goes into 20 and also goes into 12. Any more? 6? No. 8? No. No, I think 4 is, isn't it? So let's divide top and bottom by 4. Well, not top and bottom, left and right, because we're doing a ratio. Divide by 4, divide by 4. 20 divided by 4 is 5. And 12 divided by 4 is 3. So 5 and 3 are both prime numbers, so we're not going to be able to cancel them down any more than that. So the ratio in its simplest form is 5 to 3. Question 6a, Samir and Dan run a race. Samir finishes in 2.5 minutes. Dan finishes in 130 seconds. Complete the following sentence. Blank wins by blank seconds. Okay, so we need to know who is faster out of Samir and Dan. The issue is that one's in minutes and one's in seconds. So we need to get them both out in the same units. Probably easier to convert Samir's, isn't it? So 2.5 minutes. Well, there are 60 seconds in 1 minute, isn't it? 1 minute equals 60 seconds. So then 2 minutes is going to be 2 lots of 60 seconds. So it's going to be 60 and 60. And half a minute is going to be half of 60. It's going to be 30. So how many seconds is that altogether? It's going to be 60, 120, 150. So that is 150 seconds. Okay? Okay, so Samir finishes in 150 seconds. Dan finishes in 130 seconds. So who wins? It's the smallest time that wins, isn't it, in a race? You have to get past the finish line first. So I think we can say that Dan finishes first. So we're going to say Dan wins, because he does it in a shorter time. How much shorter is the time? 150 minus 130. That is 20, isn't it? 20 seconds. So he wins by 20 seconds. 6b, Alice does a sponsored walk. She starts from home on Monday at 8 a.m. She arrives back home 55 hours later. Work out when she arrives back home. Okay, so she's gone for a few days, isn't it? Because there are 24 hours in a day. Okay, so 55 hours. How many days, whole days, are there in 55 hours? 24, 48 is two days, isn't it? And I've still got some more hours. So 48. So 24 goes into 55 twice, remainder 7. So 55 hours is equal to 2 days and 7 hours, isn't it? Okay. So if she set off on Monday at 8 a.m., it's going to be 2 whole days later that she comes back. So that'd be Tuesday, Wednesday. She's going to come back on Wednesday. 7 hours. So we've done the 2 days part. We've got to add on the 7 hours now. So 2 days after Monday, 8 o'clock would be a Wednesday, 8 o'clock. And then 7 hours on to 8 a.m. So, you know, usually in the exam room, you've got like a clock on the wall. It's a good idea to use that if you've got that one. So 7 hours on to 8. So if you go from like 8 o'clock, count up 9, 10, 11, 12. That's 4 hours, isn't it? Takes you up to midday. And then you're going to get 1, 2, 3, another 3 hours after that. It's going to take you to 3 p.m. Okay, so you're going to be going in. She's going to come back at 3 p.m. on Wednesday. Question 7. Work out 43 times 8 minus 234 divided by 6. Now, the 43 times 8 are in brackets, and the 234 divided by 6 are in brackets. But actually, those brackets are not doing anything, are they? BidMaths would say you had to do the multiplication and the division before you did the subtraction anyway. So really those brackets aren't doing anything other than to really help the unwary student do the operations in the right order. I'm gonna do them as two separate things, and I'm gonna bring the answer back in a minute. So what is 43 times 8 firstly? So 43 times 8, how do you do your multiplication? Lots of different ways of doing multiplication, not just one. I'm going to do it by Napier's bones. So you make a little grid like this. 4 8s are 8, 16, 24, 32. I'm going to write my 3 and 2 in like that. 3 times 8, 8, 16, 24. I'm going to write my 24 in like that. And then I add up along the diagonals. That's how you do Napier's bones. So that's 4, 4, 3 then. So that's 344. So the bracket part becomes 3, 4, 4. And then I'm going to minus 234 divided by 6. So I'm going to do some short division here. 6 into 2, 3, 4. 6's into 2 don't go. So let's carry the 2 over. 6 is into 23. That goes in 3 times, isn't it? 3 6's are 18. So then that leaves me a remainder of 5. And then 6 into 54, that goes 9 times, doesn't it? So that's going to give me 39. So I've got 344 from the first bracket. I've got 39 in the second bracket. So now I need to do 344 minus 39. 344 minus 39. So 4 minus 9 I cannot do. So let's borrow one from there. Okay, so 14. 14 minus 9, that's 5. 3 minus 3 is 0. 3 minus nothing is 3. So that's 305. Okay, so that's my final answer, 305. Question 8. Here is some information by typical type. Question 8. Here is some information by ticket type about the number of people visiting a cinema in 1 week. So we've got adults, students, and children. How many children visited the cinema? Okay, so we've got 1, 2, 3, 4 of these kind of window-looking things, and those window-looking things represent 40 people each. So what we've got is 40 times 4, haven't we? Okay. So 4 4s are 16 with a 0 on the end, it's 160. So it's going to be 160 children. Question 8b, how many more students than adults visited the cinema? Well, I mean, there's different ways of doing this. I could work out the students and then the adults and then subtract one from the other. But actually, I'm a bit lazy, so I'm going to kind of do that visually. So this one and this one take away this one, this one take away this one, this one take away this, leaves me with this. And this is how many more students went than adults, isn't it? So it's two of these big windows that represents 40 and a half a window. So it's 2.5 windows or 2.5 lots of 40. So that's going to be like 40, 40 and half of 40, which is 20, isn't it? So there's going to be 40, 80, 100. So there's going to be 100 more students than adults in that visit. Question 8c, a bar chart is drawn to show the number of people visiting the cinema in 1 month. And we need to give one criticism of the bar chart. Okay. Well, I like the fact that they have labeled the axes, so that's all good. They're using discrete data and they've got a nice gap between their bars, so I'm happy with that. The bar widths are the same. The gaps between the bars are the same, so that's all good. But one thing that isn't good is this scale here. Starts off well enough. Look, 0, 50, 1,000, sorry, 0, 500, 1,000, 1,500, 2,000. So can you see that the scale is going up in 500s? Now a scale needs to be uniform, which means the next number up should have been 2,500, and then 3,000 should be up here on this top line here. So what they've done is they've used an ununiform. This scale is not uniform, is it? Okay, so that's going to be my criticism. The scale is not uniform. It should go up in 500s, but jumps from 2000 to 3000. Okay, probably the scale is not uniform, should be enough probably to get the mark, but you know, a bit more detail. Question 9 says Harry will pay income tax if he earns more than £12,500 in a year. After 8 months, he has earned a total of £7,600. For the rest of the year, he earns £1,200 each month. Will he pay income tax? You must show your working. Okay, so we know in 8 months he earns 7,600. So then how many months are left? Okay, so there are 12 months in a year. So 12 months in year. So 12 minus 8 equals 4 months to go then, isn't there? There are 4 more months that where he's going to be earning 1,200 each month. Okay, so what is 1,200 times 4? 1,200 times 4, that is going to be, well, 4,000s is 4,000, 4,200s is 800. That's going to be 4,800. And that's how much money he's earned in the last 4 months, isn't it? So last 4 months, that's the amount he's earned. Okay. Now, so then his total earnings are going to be the 7,600 he earned in the first 8 months plus that 4,800 he earned in the last 4 months. So what's that then? 7600 4800 00 6 and 8, that makes 14. Carry 1 7 11 12. So that's £12,400, isn't it? 12,400. And the limit is 12,500. So he's just scraped in under the limit then, isn't it? So I'm going to say this is less than 12,500, so no tax to pay. Okay? Don't forget that you need to answer the question, so you have to say yes or no, he pays tax, yes he pays tax, or no he doesn't pay tax. So I've said no he doesn't, okay, to get that last mark. Question 10, it says x is a 2-digit whole number, okay? So how many digits does the number 10x have? Circle your answer. Okay, so what range of possible values can x take? It's a 2-digit number. Well, the smallest 2-digit number is 10, and the largest 2-digit number is 99. So our value of x, it must be somewhere between those two then. So it's kind of bibbling around somewhere between 10 and 99. Okay, so then 10x, if I multiply through by 10, okay, then that tells me that my 10x has got to be between 10 times 10, which is 100, and 99 times 10, which is 990. Okay, so 10x is going to be 100 and 990, somewhere in between. Okay, so all of the numbers between 100 and 990 have got 3 digits, so it's that one there, isn't it? Question 11a, circle the answer to 50 times 0.2. Well, 0.2 is well, lots of different ways of thinking about this, but I suppose you could say it's 2/10, couldn't you? In other words, what's 50 times 2 divided by 10? Well, 50 divided by 10 is 5, and 5 times 2 is 10, so it's 10. Okay, work out 3.65 divided by 5. Give your answer as a decimal. I'm just going to do this as short division. So 5 into 3.65. 5s into 3, they do not go, so 0 times. And I'm going to carry the 3 over, so make that 36. I'm going to put the decimal place in the same place as it is, so it's 0 point. And then 5s into 36, well, 5 7s are 35, so it goes in 7 times, remainder 1 then, isn't it? Okay, and then finally 5s into 15 go 3 times. So the answer is 0.73. Question 12. The Venn diagram shows information about 50 people who are in a band. 12a says, how many of these people are guitar players? Well, you can see that the set G is the guitar players, which is this set here, isn't it? This is the G set. So everybody in here plays the guitar. So you've got 8 and you've got 21. So if I add those together, 8 plus 21, I'm going to get 29, then, aren't I? So there are 29 guitar players altogether. How many people are singers but not guitar players? Well, if they're singers but not guitar players, they have to be inside the singer circle but outside the guitar circle. So it's basically everyone in here, isn't it? Okay, so 4. There are 4 people who are singers but not guitar players. Part C says one of the people is chosen at random. Write down the probability that the person is not a singer and not a guitar player. Well, probability is successful outcomes divided by total outcomes, isn't it? Successful outcomes divided by total outcomes. The people who are not singers and are not guitar players are the people outside both those circles, isn't it? Okay, so it's anybody outside those 2 circles, which is 17. There are 17 people outside the 2 circles, isn't it? So it's going to be 17 not singers and not guitar players out of a total of, how many people there all together? 50, weren't there? Out of 50. Okay. Now 17 is prime, so I'm not, and 17 is not a factor of 50, so I'm not going to be able to cancel that down. 17 over 50. Question 13. Here is a parallelogram. The parallelogram is translated 4 squares to the left and 3 squares up. Draw the translated parallelogram. Okay, what I'm going to do is I'm going to take each of the corners of my shape and I'm going to take each one and I'm going to translate it to find where its image points go. So I need to go 4 squares to the left and I need to go 3 squares up. So I'm going to take each corner and do that. So let's take the bottom left corner first. So if I'm going to go 1, 2, 3, 4 to the left, takes me to here, and then 3 up is going to take me to this point here then, isn't it? Okay? So I'm going to do that with the rest of them as well. So then if I take the top left corner and I count 1, 2, 3, 4 to the left and 3 up, it's going to take me to there. Then if I take the top right corner, I'm going to go 4 to the left and 3 up. It's going to take me to there. And then finally, if I take this bottom corner and I go 4 to the left and 3 up, it's going to take me there. Okay? So once you've kind of worked out where each of your corners go, then you can join them up into a nice shape. Okay? Don't try and translate the shape. Translate the corners and then join them up like that. All right? So that's my translated parallelogram. Question 14a, solve 6x minus 11 equals 13. So I've got an equation involving x. I need to get x by itself, don't I? Okay. Now you've got 2 operations here. 6 times x is times by 6, and then we're subtracting 11. Now if you think about BIDMAS, it tells you the order that you'd work these things out with. When you are rearranging equations, we kind of go through BIDMAS backwards. Okay, so we do it in that in like the opposite order, or we rearrange it in the opposite order as we would with BIDMAS. So I would deal with any addition subtractions first. So I'm gonna deal with this minus 11 on the end here. I'm gonna do the opposite of it basically, aren't I? So I'm gonna add 11 to both sides. Okay, that will have the effect of cancelling that 11 there, leaving me with just 6x on the left. 13 plus 11 is 24. And then I'm going to do the opposite of timesing by 6, which is dividing by 6. So dividing both sides by 6, that again cancels the 6 with that 6 there, leaving me with just x on the left. 24 divided by 6 is 4, telling me that x must be equal to 4. Advertisement break. Looking for a maths tutor to help you through your GCSE, A-level or IB exams? Then why not check out Mr. Tompkins Tutors at mr.tompkins.online/tutors. Mr. Tompkins Tutors offers personalised one-to-one quality tuition online via Teams direct to your home. Tuition is delivered by myself and a team of first-rate teachers who I've personally known and worked with for years. All have qualified teacher status in the UK and a recent full DBS disclosure, so you can be confident that you're in good hands. To find out more and request a trial lesson, simply visit the website linked below and complete the online form, and we'll be in touch with you soon. Until then, let's get back to the maths. Well, this looks like a lot of fun. For in B, simplify fully 2 times 4a plus 9 plus 15a over 3 minus 7. Okay? Right, now it's not an equation that we're trying to solve. We're not going to go through BIDMAS backwards. We're just going to go through normal BIDMAS. Okay, so we're going to deal with brackets, then indices, and then division, multiplication, addition, subtraction. Okay, first up, brackets. Let's deal with that. That's this bit here, isn't it? So 2 times 4a, 2 lots of 4a is 8a. So I'm just going to do that bit, and I'm going to leave everything else unchanged for now. Okay. Then what? Indices, no indices. Next comes division, multiplication. Okay, so I've got some division here, haven't I, that I need to do next. 15a divided by 3. 3's into 15 go 5 times. Okay, so that leaves me with 8a plus 9 from before. And now I've got 5a there minus 7. Okay. Right, now I've just got some addition subtraction, so I'm just going to collect like terms now. I've got terms in A, I've got 8a and 5a, and I've got numbers on my constants. So I've got plus 9 and minus 7. So 8a and 5a, that makes 13a, and 9a take away 7, sorry, 9 take away 7 is 2, so that's plus 2, okay? 13a plus 2. Question 15. A pyramid has a square base. Each of the 4 sloping edges have length 10. The total length of all 8 edges is 68 centimeters. Work out the area of the square base. I know these edges, all the sloping ones, 10, 10, 10, and 10. I don't know the ones along the bottom, so I'm going to call those x. So I've got x. X is a square, so they're all the same. So I'm just going to call them the same letter, x, 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 and x. Okay? Now, the total length of all 8 edges adds up to 68. So if I can take all my 8 edges from the diagram, add them up, I should get 68. So let's do that then. I've got 10 edges of 10, haven't I? So 10 plus 10 plus 10 plus 10. And I've got x plus x plus x plus x. They're my 8 edges, and that is equal to 68. Okay, so 4 tens basically, that's 40, plus 4 x's, that's 4x, and that is equal to 68. So I've got a linear equation then in x, which I can then solve. Okay, so taking 40 away from both sides. Okay, so then that 40 will cancel with that, and then I'm left with 4x here. 68 take away 40 is 28. Dividing by 4, that's going to cancel with that, leaving me with x on the left. 4's into 28 go 7 times. Okay, so that means that this side here is 7, this side here is 7, and so on. Now we want to work out the area of the square base. So the area of a square is, well, it's side squared, isn't it? Because they're both the same. It's a rectangle with 2 equal sides. So it's just 7 times 7. It's going to be 49. And its area, so it's going to be squared centimeters. So 49 squared centimeters. Question 16. The table shows information about how 150 students travel to school. Now this is what we call a two-way table, isn't it? Where we've got one dimension going down the side, which is the gender of the students, girls and boys, and their mode of travel along the top there, walk, bus and car. Okay, so what fraction of the girls walk to school? Well, the girls walking to school are these 22 here, and there are a total of 72 girls. So what fraction of the girls walking to school is going to be 22 out of 72, isn't it? Okay. Are there any common factors there? Well, 22 has got factors 1, 2, 11 and 22. 22 doesn't go into 72, but 2 does. So dividing by 2, top and bottom. So divide by 2. That's going to give me 11 over 36. Okay. No further factors there that I can count down. 11 is prime, isn't it? So it's just 11 over 36. 16b says one boy is chosen at random. What is the probability that the boy travels to school by bus? Okay. So again, probability is successful outcomes. So probability of boy travels by bus is going to be successful outcomes over total outcomes. So how many successful outcomes are there? Success in this case is that he goes to school by bus. So there are 41 boys who go to school by bus. So it's 41 on the top. Okay, and then total outcomes then. I'm just picking from the boys, aren't I? Okay, it says one boy is chosen from random. So I'm picking from this group of boys, 78. So that is the number that goes on the bottom. That's the total outcomes. I could have any one of those 78 boys. Okay, so it's 41 out of 78. It doesn't ask me to cancel it down, so I'm not going to bother. I'm just going to leave it like that. Not sure if it does or not, but let's just move on. Part C says, what percentage of the 150 students travel to school by car? Well, traveling by car is these two here, isn't it? There's 17 girls and 13 boys. Now that adds up to 30 altogether. And there are 150 students altogether. So that's going to be 30 students out of 150 students. Now we need to write this as a percentage, okay, not as a fraction. But a fraction is a percentage over 100, isn't it? Okay. So I'm going to try and rewrite this as a fraction over 100, but often it's easier to go by a stepping stone because 150 doesn't, I can't multiply or divide 150 and get 100. But what I can do is I can double it first and go via 300 and then divide by 3. So if I take 30 1/50th and I times top and bottom by 2, I'm going to get 60 over 300. And then if I divide top and bottom by 3, I'm going to get a fraction over 100, isn't it? 60 divided by 3 is 20. So it's actually 20 over 100, which is 20%. 20 out of 100. Question 17. A straight line passes through O, which is the origin, and it goes through 2, 6. Circle the equation of the line. Okay, now to find the equation of the line, you need to know its gradient and you need to know its y-intercept. The equation is y equals mx plus c, isn't it? Where m is the gradient and c is the y-intercept. Okay, now the y-intercept is where the line crosses the y-axis, which is down there, isn't it? So I can see what c is. C is 0. C is equal to 0. Okay, so this bit is going to disappear. I'm just going to get y equals mx. Okay, so what is m? M is the gradient. To find the gradient of a line, find 2 points that you know their coordinates for. I've got 2, 6, and I've got the origin, which is 0, 0. And I'm going to kind of construct a triangle between those 2 points. Okay, right angle triangle. And I'm going to work out the change in y and the change in x and divide one by the other to find the gradient. Okay, so how long is this line first of all? It goes from 0 to 6, so that's going to be 6 units tall, isn't it? Okay, it's the y coordinate I need. It's this height here is 6. Okay, and then this value here is 2, isn't it, on the x-axis, which means this length is 2. So the gradient of this line, m, is going to be change in y, 6, divided by change in x, 2, which gives me a gradient of 3. So m is 3. So the equation of this line is y equals 3x. So let's circle this one. Question 18a, work out 110% of 80. Well, I know 100% of it is 80 to start with, isn't it? So 100% of my value is 80. What's 10%? 10% is going to be 1/10 of that then, isn't it? So 1/10 of 80 is 8. And what we want to do is we want to make 110%. Now we can make 110% by adding 100% and 10% together. So if I add these two numbers together, I'm going to get 110%. So if I add these two numbers together, I'm going to get 110%. So that is going to be 88. So 110% of 80 is 88. Question 18b, work out 21 as a fraction of 12. Now 21 as a fraction of the 12 is it's 21 over 12, isn't it? So 21 over 12 is 21 as a fraction of 12. Okay, now notice that these numbers in my answers I get to pick from, none of them say 12. But we can cancel this fraction down. We can simplify it, can't we? Because 21 and 12 are both divisible by 3. So dividing top and bottom by 3, we're going to get 21 divided by 3 is 7. 12 divided by 3 is 4. So it's that one there. Look, it's 7/4. Question 19. Bags X and Y each contain counters. Bag X has got 30 counters. Each counter is green, white or yellow. Bag Y has 5 counters and there are 3 green and 2 red. Question 19a says the probability of green counter from X is equal to the probability of a red counter from Y. Work out the number of green counters in X. Okay. Right, to work out the number of green counters in X, we first need to know what the red counters from Y are. So in bag Y, then the probability of red is going to be, well, there are 2 red ones, aren't there? And there are a total of 5 counters. So that's going to be 2/5. Okay? So that means that the probability of getting a green counter from X is the same as that probability. So it's going to be 2/5 as well. And the only way that it can be 2/5 is if 2/5 of the 30 counters in bag X are green. So what we need to do is work out what 2/5 of 30 is. 2/5 of 30. What's that then? 30 divided by 5 is 6. 6 times 2 is 12. So that's 12. So there must be 12 green counters in bag X then. So the answer is 12. 19b says all 35 counters are put in one bag. One counter is picked at random. Work out the probability that the counter is not red. We've got 30 counters in bag X. We've got 5 counters in bag Y. We pour them all into one big bag. That means we've got 35 counters in total. So if we're picking one counter from the bag, we've got 35 different outcomes that are possible, which means there's a 35 on the bottom of our fraction for our probability, isn't it? Okay, so what we need to do is work out how many successful outcomes are there, how many not red counters are there. Now in the first bag, do you remember there were green, white and yellow counters in there, and in the second bag there were green counters and 2 red counters. Okay, so the only red counters in either bag were the 2 red counters in bag Y. So that means there are 2 red counters in total, and there must be therefore 33 counters, so 35 take away 2, that are not red. All the others are not red, aren't they? So there are 33 not red counters out of a total of 35. So the probability is 33 out of 35. Hello from Mr. Tompkins EdTech. Memberships are a feature on YouTube that allows subscribers to directly support creators and to also gain better access to them. As a member of this channel, you pay a small subscription fee and in return receive a range of additional channel perks. Here on Mr. Tompkins EdTech, I provide channel members with their own loyalty badge, which is displayed whenever you comment on any of my videos. I always reply to channel member comments first, and I try to answer all their questions fully. I upload exclusive member-only videos for all you EdTech enthusiasts, and I also post early releases of my popular exam paper walkthroughs. So if you can't find the paper you're looking for yet on my main channel, you'll most certainly find it first in the members only area. As a special acknowledgement and thank you, higher tier members can even have their name appear in the credits of my videos. So if you enjoy my content and you would like to support me make more of it, and at the same time enjoy some exclusive extra perks, then why not sign up today? A and B are scatter graphs. What type of correlation is shown by each graph? And we've got a few to pick from. Now, graph A is sloping downwards from left to right, so it is definitely negative correlation. Now, is it strong or weak? Now, those points are very much sitting in a straight line. They're very close to, they're very close to a line of best fit. If I drew one in with a ruler, they're all pretty much sitting on top of it. So that is very strong negative correlation. Strong negative. Now, the second set, pretty much everywhere, aren't they? There's no correlation going on here. Okay, that's it. All the terms of a geometric progression are positive. The second and fourth terms are shown. Work out the first and third terms. Okay, so a geometric progression is one which has a common ratio. In other words, you get the next term by multiplying the previous term by a number, the same number each time. Now, a good way of writing down geometric progressions that's used quite often is we say that A is the first term, and then the second term you're going to get by taking A and multiplying it through by R, whatever that common ratio is. The third term you're going to multiply through by another R, which gives you AR squared, and then finally you're going to multiply through by another R, it's going to give you AR cubed, and so on. Okay, so I can say then that AR cubed is 16, and I can say that AR is equal to 4. Okay, so what we've got now is a pair of simultaneous equations in A and R. Okay, and what I'm going to do is I'm not going to subtract them, I'm going to divide them. I'm going to divide one by the other. Okay, so what is AR cubed divided by AR? The A is going to cancel with the A. The R is going to cancel with one of those R's there. It's going to leave you with 2, isn't it? Going to end up with R squared. Okay, and that is going to be equal to 16 divided by 4 then, isn't it? 16 divided by 4 is 4. Now that makes R root 4, which is, well, it could be positive 2 or it could be negative 2. Now, it does say that all the terms of the geometric progression are positive, so we're going to exclude the negative solution then as a possibility. Okay, can't be minus 2 because that would not give me a positive other terms. I get positive, negative, positive, negative. Okay, so now I know that R is 2. What does that make A? Well, again, from my two statements up here, my two equations that I made in A and R, I know that AR is equal to 4, and now that I know that R is 2, that means 2A is 4, and that means that A is 2. Okay, so I know that A is 2 and R is 2. So that means my first term is a, which is 2. Then I'm going to multiply it by 2 and get 4. And then I'm going to multiply it by 2 again and going to get 8. And then I'm going to multiply by 2 again and I'm going to get 16. Okay? So my first term, 2. My third term, 8. Now you could have probably worked that out by inspection, just by looking at the terms and thinking it through. But this method works no matter how difficult the numbers are that they give you. Okay, so it's a good method to know. In part B, we are given the first 2 terms of an arithmetic progression this time, and we're told that the sum of the first 3 terms is 90. Work out the value of p. Now the common difference here, what do I have to add on to p to get 5p? I'm adding on 4p here, aren't I? Okay, and then so if I add on another 4p here, 5p add 4p is going to give me 9p. Okay? So the sum of the first 3 terms then is going to be p plus 5p plus 9p. What's that then? P plus 5p, 6p plus 9p. That's 15p. And we're told that is equal to 90. So if 15p is 90, divide both sides by 15, and it will tell me what p is then, won't it? So p is equal to 15's into 90. Go 15, 30, it goes 6 times, doesn't it? P is 6. Question 22. This formula converts temperature in degrees Fahrenheit, represented by the letter F, to Kelvin, which is represented by the letter K. A pottery oven is heated to 2192 degrees Fahrenheit. Work out this temperature in Kelvin. Okay, so this is basically, it's quite a big, horrible looking formula, but really all we're doing is substituting, aren't we? We know that it's 2192 Fahrenheit, so we need to take this number here and we need to plug it into the formula here at F. Okay, so we're going to rewrite F as 2192, and then we're going to have to work out, we're just going to have to work out what that calculation is then, aren't we? So the Kelvin then is going to be 5/9 of F, which is going to be 2192 minus 32 plus 273. Okay? Right, now we're going to need to follow BIDMAS here, aren't we? BIDMAS, because it's quite a complex formula. So we're going to start off with brackets. Brackets. So we're going to do that bit first. Okay, I'm just going to do it line by line, step by step. So 2192 minus 32. So that's going to be what? 2160 plus 273. Okay. So I've done all my brackets. Next up is division multiplication. So basically I have to find 5/9 of this, don't I? 5/9 of 2160. Okay. Now I'm going to start with the division because that's easier to do the division first. So 9's into 2160. What's that then? 9's into 2160. So 9's into 2 can't go. Carry 2. 9's into 21. That goes twice, doesn't it? And then the remainder is 2 9's are 18. The remainder is 3. So then 9's into 36. Well, that does go exactly. That's 4, isn't it? 4 9's are 36. So then that's going to be 240. So when I divide by 9, I'm going to get 240. Remember, I need to then times by 5. So what's 5 lots of 240? 240 times 5. Now times by 5, I kind of halve it and then times it by 10 because I find that easier. So half of 240 is 120, and then 120 with an extra 0 on the end is 1200. That's 1200. Okay, so that's 1200 plus 273. And then finally, look, I've got my last step of BIDMAS, which is addition, subtraction. It's that bit there. Just need to add these two numbers together. So that's 1473 Kelvin. So Kelvin is 1473. We did it. As a decimal, 11/40 is 0.275. Work out what 33/400 is as a decimal. Okay, so these are quite closely related, these two fractions, aren't they? So we could take 11 over 44, and now if we multiplied it by 3, okay, what's that going to give me then? That's going to give me 33 over 40, and that's going to be equal to 3 lots of 0.275. So tripling that up, it's going to be what? 600 and 375s, 225. That's going to be 0.825, isn't it? 0.825. Okay. And then, how do I go from 33 40ths to 33 400ths? I can do that by dividing both sides by 10, can't I? So divide by 10, divide by 10. Okay, so 33 over 400 on the left, dividing that by 10, it's going to be 0.0825, just shifting it 1 unit to the 1 decimal place to the right. Okay, so 33 400ths is going to be 0.0825. The cost of a holiday is £2,400. Rana pays a deposit followed by monthly payments in the ratio of deposit to total monthly payments in the ratio of 3 to 5. She makes 6 equal monthly payments. Work out her monthly payment. So let's start by taking our total cost of the holiday and dividing it in the ratio of 3 to 5, so we can know how much the deposit was and how much the total of the monthly payment is. Okay, now we can do that by taking the 3 and the 5 from the ratio and adding it together. 3 plus 5, that gives me 8. That tells me how many shares there are altogether. 3 shares for the deposit, 5 shares for the monthly payments, 8 shares altogether. Okay, so we're going to divide 8 into 2,400 to find out what each share is worth. 8s into 2 don't go. 8s into 24 go 3 times. Remainder 0 is going to be 300, isn't it? So 8 goes into 2,400 3 times. 300 times. So each share is worth 300. Okay, so then taking our ratio of 3 to 5 and scaling it up by a factor of 300, that is going to give me 3 times 300 is £900 for the deposit, and 5 lots of 300, that's going to be 1,500 for the monthly payments. Okay, so we've got £1,500 to pay in monthly payments, and we're going to be paying it in 6 equal monthly payments. So now we've got to divide our 1,500 by 6. Okay, so 1,500 divided by 6. So 6 into 1 don't go. 6 into 15, well, that goes twice, and the remainder is 3. 3s into 30 go 5 times. So that's 250 then, isn't it? Okay, so that means that each monthly payment is going to be £250. Question 25, factorise fully 2x squared plus 6x. Now, factorise means put brackets back in, and factorise fully means that there's going to be more than one factor to pull out and put at the front of your brackets. Okay, so when you're factorising, you're looking for things that are common in the various terms of your expression. So immediately I can see that they've got an x in common. So you've got an x in here, and you've got 1 in here as well, haven't you? So we could bring x out in front, outside the bracket, but there's also another common factor here. 2 and 6 both have 2 as a common factor, so I can bring the 2 out as well. So actually the common factors are 2 and x. And then inside the brackets you need to put in what you have to multiply by 2x to get your various terms. So what is 2x times, 2x times what is 2x squared? I'm going to multiply that by x, aren't I? 2x times x is 2x squared. And then to get 6x from 2x, I'm going to have to multiply that by 3. Okay, so I factorized it fully because I've pulled out all the common factors, not just one. Okay, now if you want both marks, you do need to get both factors. If you just factorized out the x and got 2x plus 6, that is factorized, but it's not factorized fully. Similarly, if you just pulled out 2x squared plus 3x, again, that is not factorized fully. You have to bring out the 2 and the x to get both marks. 2 wire shapes make an earring. The shapes are a circle with radius 21 millimeters and a quarter circle. Now the radius of the circle to the radius of the quarter circle is 7 to 2. Show that the radius of the quarter circle is 6 millimeters. Okay, well the radius of the top one is 21, isn't it? Okay, so if these are in the ratio of 7 to 2, and I change 7 to 21, I'm multiplying through by 3, aren't I? Okay, so if I do the same thing to this side, then that's going to give me 6. Therefore, the radius is 6 millimeters. Okay. Part B says, work out the total length of wire in the earring. Give your answer in the form a pi plus b, where a and b are integers. So this bit here just means leave pi in, don't have to times by 3.14 whatever, which is nice, seeing I don't have a calculator. Right, so let's break this down. So this shape is made up of 2 shapes. It's made up of the circle and the quarter circle. Now the circle is pretty straightforward. The perimeter of the circle is just the circumference of the circle, isn't it? So the circumference of a circle is pi times its diameter, or another way of writing that is 2 pi r, isn't it? Okay, so that's going to be 2 times pi times the radius, which we know is 21 millimeters. Okay, so that's going to be 2 pi times 21, which is 42 lots of pi, isn't it? Okay, so that's all fairly straightforward. Now the perimeter of the quarter circle is not quite so straightforward, because the perimeter is going to be made up of this part here, which is a quarter of a circle, plus these 2 sides, which are 2 radii, aren't they? So that's r, and that's going to be 2 pi r over 4. 2 pi r over 4. So for whatever value of r we've got. Now we worked out here that the radius is 6. So our perimeter is going to be 2 pi r, which is 6, divided by 4 because it's a quarter of a circle, plus 6 for the radius, plus 6, isn't it? So what's that then? 2 pi times 6 is 12, divided by 4 is 3 pi. So that's 3 pi plus 6, which is 12. Okay, so then the total length of wire required, total length, is going to be the circumference of the circle plus the perimeter of the quarter circle, which is going to be 42 pi plus 3 pi plus 12. So 42 pi and 3 pi make 45 pi, and then we've got that 12 left over for the 2 straight sections of the smaller quarter circle. Okay, and now that's in the form a pi plus b, because we've got a multiple of pi plus a number. Okay, so we're good. That's it. Use trigonometry to work out the size of angle x. Okay, very straightforward trigonometry question. Okay, first up, let's label the sides. The long side is always opposite the right angle. It's that one there. It's the hypotenuse. This one over here is the opposite, and this one must be the adjacent, isn't it? So I've got the adjacent and I've got the hypotenuse, and I want to find the angle. So, writing down my mnemonic SOHCAHTOA to help me remember which ratio to use, you can see that the ratio involving a and h is this one. It's the cosine, isn't it? So I'm going to write down cos theta equals adjacent over hypotenuse. This is the trigonometric ratio for cosine. And then we're going to sub in the values from our diagram. Theta is the angle, so it's going to be x. So cos x equals, the adjacent is that one there, look, it's 9. 9, and the hypotenuse is that one. It's 18, isn't it? Okay, So it's 9 over 18. Okay, so 9 over 18, that's the same thing as a half, isn't it? Okay, so we've got cos x equals a half. Now, what angle has a cosine of half? Now, we don't have a calculator in this paper, but we do, or we should, have a knowledge of certain angles, our exact trigonometric ratios that we need to learn. I'll just pull up the table of all the values here, and you should see that the angle that has a cosine of a half is cos 60, isn't it? It's 60 degrees. Okay, so that tells me then that x equals 60 degrees. Now, the only way of really doing that is knowing these angles, so you've just got to memorize this table. It's not as daunting as it first looks. It's just something you've got to do. Right, let's move on. Question 28, rearrange c equals d plus 2 over 3 to make d the subject. Now, we talked about rearranging equations earlier and the fact that you kind of have to do inverse operations. And it kind of ends up meaning you have to kind of work your way backwards through these steps in the opposite order that you would normally do BIDMAS. So you would deal with addition and subtraction first, then division, multiplication, indices, and then brackets. Okay. Now, when I've got c equals a d plus 2 over 3, doing that would kind of imply you have to deal with the addition first. But because this division line goes all the way across those two things, actually you've got an implied pair of brackets around that d plus 2 because you are adding d and 2 together and then you're dividing everything by 3. Okay, so there's an implied pair of brackets around that d plus 2, which kind of bumps up the order of operation. So when we're kind of unwinding it, it kind of pushes it further down the list, so to speak. So rather than dealing with that addition subtraction first, we're gonna deal with the division and multiplication instead. We're gonna do the opposite of dividing by 3. So I'm going to times both sides by 3. That's going to give me 3c equals d plus 2. Okay, and then I'm going to deal with that implied bracket there. Okay, so I have to do the opposite of adding 2, which is taking 2 away. So I'm going to take 2 away from both sides. That is going to cancel with that, leaving me with d on the right. I'm going to get 3c minus 2. So d equals 3c minus 2, not d, 3c minus 2. Question 29a, write 360,000 in standard form. Now, when you write a number in standard form, you use the same digits. So I'm going to use 3 and 6, but I'm going to change where the decimal point is. I'm going to put it in between the two. This is what we call the mantissa part of your expression. It has to be a number between 1 and 10. So you have to place the decimal point in such a way as it creates a number between 1 and 10. And then we're going to multiply through by a power of 10. And think, well, what would I have to multiply 3.6 by to get 360,000 back again? Now, the number you can get quite easily by just counting the number of digits you've got after where you put the decimal point. So I've got 1, 2, 3, 4, 5 in there. So this is going to be 3.6 times 10 to the 5. Okay. 9.2 times 10 to the minus 3. When you've got a negative index, that means you've got like a decimal number, not a big whole number. So 9.2 times 10 to the minus 3, it means I'm going to take my decimal point and I'm going to move it 3 places to the left this time. 1, 2, 3. It's going to kind of end up going there. And then I kind of fill in zeros either side of that. So 0, 0, 0. So I'm going to get 0.0092 as my answer. 0.0092. Job done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.